All right, so lesson 55 is on counting principles, permutations, and combinations. So it says you've seen problems involving these before, so in Algebra 2, you should have seen it. But let's see how much you remember. So it's okay if you have not seen it, do not remember it, it's fine. So I've told you before, my nieces and nephews are named Eleni, Bridget, CJ, and Devin, which is very convenient for these types of problems, A, B, C, D. So how many ways can they place? So they're running in a race. How many ways can they place? All right, so what we do is we think about first place. There are 4 people that could cross that finish line first, right? Eleni, Bridget, CJ, and Devin. Let's say that Devin is the fastest, right? And he gets past first, or he gets past the finish line first. Then how many people could now get second place? 3. Yep. And then 2, and 1. Exactly. So we can put all of those together, and we could say, okay, well, all the things with Devin first, and then it could be, A, B, C, or it could be B, C, A. I mean, you want to put all of those different combinations together. So we end up getting 4 times 3 times 2, which is 24.
Could we just do exclamation point?
4 factorial, you could do that as well. So how many access codes can you have if the first 2 characters have to be letters and the last 2 characters must be digits from 0 to 9? Assume you are allowed to repeat the letters, but you can't repeat the numbers. So the first ones are letters.
26 letters in the alphabet.
There are, and you can repeat. And then there are 2 numbers, 0 through 9, but you can't repeat. Okay, so a lot of personal identification numbers are like that, where you can't repeat because it's really weird if you have a bank card and your code is 1111, because that might be the first thing that someone tries, right? So a lot of times you can't have things that can't repeat, or they can't be next to each other or something like that. All right, so letters. Alex tells us there's 26 letters in the alphabet. So, I made a mistake. Should I put 25 there?
No, you should put 26.
Why should I put 26? Exactly. Because you can repeat the letters. Exactly. And then 0 through 9, we cannot repeat those.
So 9. So 10.
Ah, is it 9? It's 10 and then 9.
So.
Yeah, 0 is a digit as well, right? So 1 through 9 would be 9 numbers, and then counting 0 as well becomes 10 numbers. And now we say 9 because whatever letter you pick, or whatever number you pick there, you can't pick again. Okay, so if you picked 2, then the next one can be 1 or 0, 1, 3, 4, 5, 6, and so on. All right, so we multiply those together. And we get a total of 60840. All right, there are 5 sophomores that want to be chosen for 2 stewardship positions. How many ways can the representatives be chosen?
Well, that's a combination.
It is a common. Look, Alex. Alex remembers all of this from algebra. Do you guys remember it from algebra 2?
No.
All right, he says that it's a combination. Okay, what a combination is just picking. What it is it's just picking a group of students, but it doesn't matter what order they're in. So with stewardship, does it matter who was selected first? It doesn't. They have the same position. Okay, so what we're going to do is we're going to do C5, choose 2.
What about this?
Yep. And you can do it on your calculator. If you were putting this into your calculator, you would put 5 in, and then we do math. So 5, math. You'd arrow over to PRB, or probability. And then you would choose option 3, which is NCR. And then you would put in the 2. Oh, wait, was it 3 or 4? My different calculators are different things, I think. It's 10, you're right. All right, and now what this is doing is basically it's doing a permutation, which is like where you say 5 times 4, which would be 20, right? But it's taking out anything that's been repeated. So going back to Eleni, Bridget, CJ, and Devin, what if I had Eleni and Bridget on a committee? That's the same as Bridget and then Eleni, right? Does that make sense? So we end up dividing by 2 times 1, 2 factorial. So if I had 5 choose 3, I would do 5 times 4 times 3 for the 3 different positions. But I'd say, well, ABC is the same as BAC, which is the same as CAB, and so on. So I would divide by the number of ways to arrange 3 different items, which is 3, 2, 1. Okay, that's what a combination is. It's dividing out by the number of ways to arrange those 3 items. Okay, and then that would end up giving us the 10. All right. Do you guys remember 5 choose 2 is the same as 5 choose 3? Tell me why.
But it doesn't matter what order it is.
You're either picking two people who are going to be, and then you're essentially choosing
Yeah.
two people who aren't.
Exactly. You're either picking 2 people to be the really cool stewardship representatives, or you're picking 3 people to not be the stewardship representatives, right? They're the same thing. The number of ways you can do that, it's exactly the same. All right, so the fundamental accounting principle I often will call the slot method because I draw little positions. I draw this little slot. It says if there are A ways to do event 1, B ways to do event 2, and C ways to do event 3, then the total number of ways to do events 1, 2, and 3 would be A times B times C, right? You would just multiply them together. So you would have these little slots. But permutations, you want to think of positions, places, presidents, anything like that where the order does matter. So I say presidents because a lot of times there's problems like you have a student council where 10 people are running for any position and they could be president, vice president, secretary, or treasurer, right?
It's kind of important.
It matters, yeah. It matters which position they're getting, right? So if there are n items that must fit in r positions, then we do NPR like that, which ends up being n minus r factorial. Oh, whoops, I did that wrong.
I remember that.
It's been a while. N factorial over n minus r factorial. So I never like memorize the formula. What I do instead is if I have like 8 people and then maybe like 3 positions, like gold, silver, bronze, then I do 8, 7, 6. Does that make sense? Do you guys see how the 5, 4, 3, 2, 1 is cut off? It's gone. It's been divided out. All right, so that's where that formula comes from. And then combinations, it's very similar to permutations. So it would be NCR. And it starts out the same as the permutation formula, but we have something additional on the bottom. Does anybody remember what else we have on the bottom?
Times R.
R factorial, yep. Because you're dividing by the number of ways that you can arrange those R items. Okay, so there are, yes,
So for permutations, the order does matter, but
permutation order matters, combination does not. Combinations are like clubs and committees where everybody has the same job. You're just picking a group of items. Okay, so the calculator writes it as like this little NPR with subscripts. I write it a lot of times like this. So just know that, you know, you could see different notations. For NCR, you could also see it kind of looks like a fraction. It would be like N choose R like that. You might see that as well. Does that make sense? All right, so number 1, a baker has 4 different types of frosting, 3 different kinds of sprinkles, and 5 different flavors of cake. How many different cupcakes can be created if she uses 1 frosting, 1 color of sprinkles, and 1 type of cake?
Order does not matter.
Order doesn't matter.
The sprinkles should go on top.
This is really just kind of a slot one, right? It's saying I'm going to pick the frosting, I'm going to pick the sprinkles, and I'm going to pick the cake. And there were 4 choices for frosting, 3 for sprinkles, and 5 for cake.
60.
So there's 60 different cupcakes that she can create. Yum, cupcakes. All right, good on that one? We like the slot method, right? All right, Noah. Oh, no, you're up. Noah has 6 pairs of pants and 8 shirts in his closet. That's it, Noah. Man, slim pickings. He wants to wear a different combination each day without repeating or buying new clothes for as long as possible. Some people do this. Have you heard of like the, I don't know, like the 21 item closet or something? Yeah, and you just have to like switch it up. So how many ways can he do this? So he wants to wear a different combination each day without repeating or buying new clothes for as long as possible. So he's just picking 1 pair of pants. He's not going to wear all 6 pairs of pants, right? He's picking 1 pair of pants and 1 shirt. Although you are wearing 2 shirts today. I don't know. We can mix it up. All right, so we're going to pick the pants and we're going to pick the shirts. He has 6 choices and he has 8 choices. That's it, right? Just multiply them together. We get 48.
Wow.
All right, we're going to get harder with those. We're going to do the ones where you are packing a suitcase in a little bit.
Oh, and then you can take like 4 pairs.
Uh-huh. All right, a certain state has license plates that have 2 letters followed by 4 numbers. Letters and numbers cannot be repeated. How many different license plates could they have? So the letters would be 26 and 25. The four numbers are 10, 9, 8, and 7. That's how it used to be. They used to, like in Indiana, it was, actually no, it was like remember it was the counties. I told you that, guys, that last year. So we multiply them together.
And we get a big number.
Yes, a very big number. All right, 3,276,000.
We want to be cautious about that.
All right, here's a tricky one. We didn't do these in Algebra 2, but let's think about it. 20 people in a classroom shake hands with each person one time. How many handshakes can occur?
Well ordered.
Okay, so what if,
Slot.
what do you think?
380.
Why are you saying 380? What would you do? Oh, you did 20 times 19? Close. Okay, but when you do the 20 times 19, what that counts is like the pair Catherine, Julia, but also Julia, Catherine. Does it make sense? So what do we need to divide out by?
2.
2, because we've counted those people twice. Does that make sense? So it ends up being a combination. It's like 20 people, you want to select the 2 that are going to shake hands. So it's saying if you have 20 people, select 2 to be how many ways can you select a pair? So it ends up being the 20 times 19 over 2 times 1. Do you want me to write it out that way so you guys can see it? So we get 190. Oops, 90. Oh wait, did I do that right? Yeah, 380, okay. So a group of friends decide to go to the movies. Tyler and Ben bring their dates. Oh, Tyler and Ben.
Oh, like
And 2 of their buddies tag along. When the friends arrive at the theater, there are only 6 seats. How many ways can the 6 friends sit in a row?
Well.
6 times 5 times 4 times 3 times 2 times 1. In other words, 6 factorial, right? That ends up being 720. So there's 720 ways they can arrange themselves. So how many ways can the 6 friends sit if Tyler and Ben want to sit next to their dates? That's more important, right? If they want to sit next to their dates. So what would we do then?
4? No.
Yeah, it's kind of 4 factorial. So basically, like Tyler and his date.
Who's the date?
I don't know. Who is it, Tyler?
I don't know.
Some lucky woman. Okay, 2, 3. Okay, so that's, whoops, we don't need those 2 last ones, do we? So then they have 2 friends, right? Friend 1, friend 2. So we're treating them together. Tyler plus date, Ben plus date. They're one person. Okay, so we have the friend and the friend. So we're going to set it up. We're going to start out with 4 factorial, but that's not totally correct.
So you'd have to multiply it by 2?
Uh-huh, so you could also have, date and then Tyler, and then Ben and then date as well. So that doubles our choices, so we multiply by 2.
No, what do we multiply
And,
by 2?
yep, you could have date and Tyler, and then date and Ben in that order. Do you guys see? Like you could switch them where they're sitting. Like one could sit on the left, one could sit on the right, and you could switch those. So you're gonna have times 2 times 2. Yeah, but that's counted in that original rearrangement. Yeah, that's true. All right, so we have 24 times 2 times 2. So we get 96 is the answer. Tricky, huh?
So does that fit neatly into like any of the permutation or?
Not really. You just have to think through it. Yeah, a lot of probability can be really hard. Like you have to think, oh, well, I could also do this and this. Like you're just kind of thinking about like it's accounting, basically counting principle. All right, there are 6 points equally spaced around a circle. All right, how many quadrilaterals can be formed by joining 4 of these points? Quadrilateral. What's a quadrilateral?
It's a 4. That's square.
Could be a square. Could be rectangle. It has 4 sides, right? How many corners does it have?
4.
4. So for 4 vertices. So I could take, these 4 and create something. Or I could take these 4. Or I could take these 4. I mean, there's a lot of different combinations. What am I doing when I'm picking the 4? It's a combination, yeah. You have 6 of them, and you're going to choose 4 of them. All right, so we're going to do 6 points, and we're going to select 4. So it would be 6 times 5 times 4 times 3, all over 4 times 3 times 2 times 1. Right, it's like the permutation divided by the number of ways you can rearrange the 4.
And then would you divide it by 6? Or are you counting like a same shape but in a different position instead of a different shape?
Yeah, those are going to be different, yeah. So you get 15. All right, now I did a lot of work there with my cancellation. I did 6 times 5 times 4 times 3 all over 4 times 3 times 2 times 1. Do you remember this? 6 choose 4 is the same as 6 choose 2. So couldn't you just do 6 times 5 over 2 times 1? Do you see how that worked out here? That's why it works like it does. Okay, so you end up getting the same thing. You get 15. All right, so how about this one? So suppose you have the following dot diagram. How many triangles can be formed by these 3 points? So what am I going to start it out with?
Combination.
It's a combination.
You do C, 6, 30.
Okay. And when we do that, 6 times 4, 5 times 4 over 3 times 2 times 1. So our 6, 3, and 2 cancel, so we get 20. All right, is that our answer?
No, it is not.
What 3 points can you not join that create a triangle? That won't create a triangle. Wait, to double negative or something. What 3 points would not create a triangle?
The top 3 or the bottom 3?
Exactly. Do you guys see if you chose those 3? Or if you chose those 3, it's not a triangle. So subtract out 2. Top line and the bottom line. So our answer ends up being 20 minus 2, which is only 18. Okay, so again, it's a little step up from Algebra 2. So Algebra 2, we would have just done problems that involved like 6 choose 3. But now we have harder ones. Yes. You get it? Are you thinking the up and down ones? Okay. All right, so how many 5-card hands can be created using a 52-card deck? I don't typically do card problems because a lot of you guys don't play
Is
cards.
that 52 choose 2?
Almost. He says 52 choose 2. It's almost right. But how many am I choosing actually? 5. Yeah, I'm choosing a 5-card hand.
Oh, that's what I meant.
So it's going to be 52 choose 5. So the number of hands that you could get in poker, this is one that I would have to do on my calculator. Can you imagine doing 52 choose 5? Well, it would be 52, 51, 50, 49. We might as well do it on our calculator. All right, so we're going to do 52, math, arrow over to probability, NCR, choose 2. Or choose, dang it, choose 5. You got 2 in my head now, Alex.
Sorry.
I was like, that's not the right number. All right, 2598960. Every mathematician knows that number because they've all had to write it down.
The card trick.
Lots of card problems. So like I was saying, I don't typically do card problems because in the past when I've asked students, how many ways can you get a full house? They're like, what's a full house? Or how many ways can you get a royal flush? They're like, I have no idea what you're talking about. Like, you guys just don't play cards as much. You will once you get to college. You'll play lots of cards. Euchre, hearts, spades. It's a skill you must learn before you go to college.
Poker?
Poker, sure. All right, from a group of 20 people, 12 jurors must be selected. In how many different ways can the jury be selected? Does the order matter?
No, Jack.
I don't think it does on a jury. I've never sat on a jury. But yeah, it's just 20 choose 12. So again, put that in. So you get 125,970. All right, find the number of ways to rearrange the letters in the word Elijah and beekeeper.
1, 2, 3, 4, 5, 6.
All right, so how many letters do I have in the name Elijah? 6. Do you guys remember the trick? Yes, Eli is my son. His real name is Elijah. He's always like looks at me like, what? Why did you just call me that funny thing?
Wait, is beekeeper?
All right, beekeeper is not my son's name, no, but he's terrified of bees. All right, so how many repeats do I have? I don't have any, right? So usually in this formula, we divide by the number of repeats, but we don't have any repeats, so it's just 6 factorial, which ends up being 720. So basically we're saying we have 6 spots in those 6 spots, I could put an E, an L, an I, a J, an A, or an H. But once I choose that, then I put the E, the whatever. Emily, are you paying attention? All right, so this one, beekeeper. How many letters do I have in the word beekeeper?
Well, you gotta repeat it.
Looks like 9. Are there 9 letters? All right, how many B's do I have? 1. How many E's do I have?
5.
5. How many K's do I have? 1. How many P's do I have? How many R's do I have?
Oh no.
1. So this is what we're worried about, the number of E's. So we divide by 5 factorial. Now, if there had been like 2 P's or something, we would also do 2 factorial, right? So depending on what else we have, we might have other numbers down here.
So 24.
What are you getting 24? What you doing?
Oh.
All right, so if you have 9 factorial or 5 factorial, do you guys remember? You could write out, it gets a little bit annoying, 5, 4, 3, 2, 1. Did you add them maybe? I don't know what you did.
I did 4, 5, 4.
All right, so basically the 5, 4, 3, 2, 1 goes away. So when I see 9 factorial over 5 factorial, I just write out 9, 8, 7, 6. And I'm like, okay, 5, 4, 3, 2, 1 is divided out. Gone. So if I do 9, 8, 7, 6, I end up getting 3,000. Oh, you just forgot the first part of it.
Yeah.
Yeah, you forgot the 3,000. Okay. All right, does that make sense? Do you guys remember that formula too? Have you ever seen this, Noah? Did you guys do this stuff in Garen? Yeah. All right, so that's the end of that one. So
That's your last lesson.
I know my last lesson for maternity leave. So sad.
This is gosh, we're